This talk, unfortunately, I'll not be showing any code snippets, no live demos. That's not. This is more about patterns, design, how to build a scalable, real world, not your POC local code, but real scalable GenAI product. Let's get started. So, what do I have in store for everybody? First, some introductions about me and about the work we do at ING. Then I want to share why we thought we needed GenAI. This is where I will tell why ING as a bank chose to adopt GenAI and what purposes did we have in mind. Finally, I will share what challenges we faced when we made this choice, and more importantly, as a bank, how did we ensure a risk-free approach, a safe approach. So this is me in high def. My name is Ayush. I work for ING Bank. Specifically, I work for global assisted platforms area. This is a photo of me traveling from Harlingen to Terschelling. Terschelling is a West Frisian island in the north of Netherlands. For those who don't know, I myself live in Leeuwarden in Friesland. So global assisted platforms, we deliver a lot of stuff. One of our biggest offerings is we provide internally to ING a platform known as Contact Center 2.0 or CC 2.0. This is a platform that delivers assisted communication. So all countries where ING has a significant presence, there this platform is used to connect ING customers to ING employees, assist them. And this communication is omni-channel. So if a customer contacts ING via chat, voice, email, video, this is the platform that is orchestrating all those conversations. It's a SaaS offering, more like AWS Lambda, where our tenants, all these local countries, they don't own any infra or any code. They just own some configurations. We as a platform have a bunch of microservices, UI components, APIs, that execute these configurations for them. So it's the platform that owns everything. The platform is a combination of many microservices and many UI components. We also use Twilio. So Twilio is our vendor to deliver these programmable contact center application. This is the platform in high level. We are live in 9 countries. So in all these 9 countries, most of them in Europe, whenever a communication happens between an ING customer and an ING employee, this platform is the one that's doing it. We have a lot of vendors that we use. As I mentioned, Twilio with their APIs. We also use Calabrio and Google Dialogflow for some use cases. Now, I want to talk about the virtual assistant service. This is again an internal ING service, which is the AI system of the CC2 platform. It's again, like CC2, it's a platform that connects ING customers to ING virtual employees, also known as bots. So virtual assistant service developed or is a wrapper around Google Dialogflow, and this is what our tenants use to build their chatbots and callbots. Each ING business unit, each ING country configures its own logic based on local rules, local requirements, local regulations. They configure their agents, their intents, and the platform, the VS service, executes them on behalf of them. So again, the platform owns all the APIs and services. The local countries just own configuration. Yeah, and this is important because when we are connecting to Dialogflow, we have a sort of compliance checks, regulatory checks. So having this central service ensures a standard ecosystem for all the countries. Just to give some idea of the scale of the platform, I talk about only chat here. We are live in 6 countries with chat and chatbots. We started with this platform for chat in 2018 with the chatbot part. This is a dashboard showing a new chat start moment in a 24-hour period. During a peak working hour, we have around 1 new chat that starts with a chatbot every second. And that means we serve around 1 million chat on a monthly basis. That's the scale of the platform that we have. So we have been running this platform with traditional NLP-based chatbots for quite a while now, and they have been quite successful. But when GenAI came, we did decide to use this technology into our chatbots. The question is why? The answer here is in terms of the limitations that we saw. Uh, these chatbots that we have, the old ones, they were quite capable of answering customer questions, sometimes reducing the requirement of a human agent. But there were some limitations. The biggest measure of the limitation is how many times a customer was handed over from a chatbot to a human. That's called deflection rate. We saw that with chatbots, only 40 to 45% questions were answered, and the majority remaining questions were requiring a human intervention. So the customer said to the chatbot, "No, I don't understand your answer. Take me to a human agent, please." So there were limitations, and that's because these NLP chatbots, they work on predefined flows. So when you configure a chatbot in Google Dialogflow, you can define a flow, and then you are limited by the flows that you have. So you have a flow for, say, example, credit card, for mortgages. But if there is a different question, yeah, it doesn't know the answer. Also, it doesn't know how really to answer free-flowing text. It can't really provide a natural conversation. It can tell you what is the card limit for your card, but if I ask a question like, which account is more suitable for me, that's a free-flowing open question that the bot, a traditional bot, cannot answer. And this makes the NLP-based traditional chatbots less scalable. They do have the capacity to answer customer questions, but they're not personalized. And in today's era, I think customers are looking for a more personalized communication at every level. So that's where we saw that there were limitations specifically with this setup that we had. So how could we overcome those problems? How could we make the communication more personalized, more free flow, more human-like? We came up with this solution of conversational AI. And what is conversational AI? It's a move from a traditional NLP architecture to a more conversational AI architecture. This is where we will use the power of GenAI to provide more natural flows, more conversational flows. But this is something very challenging, because if we use GenAI to fill the gaps we have a brownfield product. It's not like we're starting from scratch. We are already live in so many countries. It's an existing, well set up product used by so many millions of customers. We have to be very careful when we transition from an old chatbot to a new chatbot. But this is not specifically for GenAI, right? Whenever there is a new hype technology out in the world, people adapt it, especially in enterprise, and they run into some very common problems. For example, I mentioned vendor lock-ins, problems with inconsistent customer journeys, problem with shadow IT. You make something work, and then you forget about it, and then nobody remembers how it was working. These are the kind of risks that do come when you introduce a new hype technology into an existing brownfield solution. So our goal was to have a conversational AI platform, but do not introduce any new gaps in our offering. So specifically, if we had to build a safe, scalable GenAI-powered chatbot, what did we need? We had to overcome a few challenges, and I list the important ones here for the sake of time. Accuracy. This is the biggest one for any financial institution. We wanted our GenAI chatbot answers to be accurate and factual. If you have heard GenAI powered by large language models, they have this tendency to hallucinate, which is when they are not factually correct. This is something that you as a financial institution cannot afford at all. So our GenAI responses had to be always accurate, without any biases. We also wanted to ensure that the customer experience is superior, because although we are using large language models and they can have slowness, the slowness can be various reasons, technically because of token generation or the high temperature settings or blah blah blah, but the customer doesn't care about that. Yeah, for him it's he is looking for a response in real time. uh, they still wanted answers in real time fast, even if it appeared more human like. And also, Gen AI is and still a very evolving technology. We want it to be always in control of our changes, even when working with this dynamic landscape. And finally, because ours was a multi-tenant platform, we wanted to have complete performance isolation. So these challenges we had in front of us, how did we solve them? Let's look at the solutions we came with, and let's go through them one by one. The first one, a big recommendation from us, is a hybrid architecture. When working with a new technology, don't throw what you already have, keep what is working for you, and then adapt or build upon it. Meaning, how does this work for us in terms of chatbots? So, uh, Google has a conversational AI platform where you can build hybrid agents. And what are these hybrid agents? They basically have two sort of properties or two sort of capabilities. You can have intent-driven agents, which follow structured customer interactions. So if you have predefined structural questions, workflows, then you can still use the old NLP bots like we had earlier. But in addition to that, you could also use generative AI when needed to provide more context-aware, free-flowing responses. These are GenAI generated responses that are more natural and don't cover existing rules or workflows. So this is the architecture that we have in Google Conversational AI Platform. You have Dialogflow CX, which is where you configure flows and you determine intents and you provide answers to predefined questions. But on the right side, you can also now integrate them with Google Vertex AI and Conversations. And that means you now have the normal NLP agents powered by GenAI agents that could provide a more conversational flow. And for us, that basically meant that in our architecture, we still had the VA API in the center, which is the gateway for ING for all AI communication to Google. But within Google, we also had the power to now connect to Vertex AI, which is more of a LLM garden. And this is very important, right? Because this basically meant we could retain our existing bots while doing a plug and play with GenAI. We could define GenAI flows within existing flows. So for example, we would start a customer with a normal NLP bot with buttons and all. But then when he chose a specific product, like he was in a specific flow, for example, mortgages, we could then enrich his experience by directing him to a GenAI flow, where the data would be more enriched, more personal, and more human-like. So this control that we got, that we could just plug and play GenAI flows within existing flows, is very important because this gives us control on where we want to use GenAI and where not. There are some products where we don't prefer to use GenAI at all because, yeah, that's too risky for us. So this architecture is what is helping us do that. This was our first solution, a hybrid model. The next solution that we went for is something that is quite common and well tested and especially well used in a lot of financial environments. The problem that we were trying to solve is accuracy, right? We wanted our chatbot responses to be factual. Here we leveraged what is known as a RAG pattern. Before I tell the pattern, I just want to read this quote from Martin Fowler. He's a well-known software developer, author of many awesome books. A common metaphor for an LLM is a junior researcher, someone who is articulate, well-read in general, but not well-informed on the details. He's overconfident, preferring to make up an answer rather than admit ignorance. So basically, with RAG, we are giving this overconfident person a question, but also some set of documents saying, hey, read these documents before you come up with an answer. Uh, so what does that mean? RAG, or retrieval augmented generation, is a pattern where an LLM is fed with some contextual data from an external knowledge source before coming up with an answer. So this actually prevents the LLM from relying only on pre-trained knowledge. It reduces the hallucinations and improves the response accuracy and reliability. And how did we do this for our purpose? So again, with Google, we have a concept known as data stores. And that's what you see on the right on this side, data stores. So the Vertex AI powered agents, they are capable of retrieving knowledge from structured and unstructured data sources. For example, for us, this data source could be our publicly available websites, which we could feed into these data stores. And then the LLM would use that content to generate a response. So by using this technology or this idea, we enable our chatbot to handle, let's say, complex real-time queries. For example, a question like, what is the current interest rate, or what is the eligibility of a loan? You want factual, correct answers. And that's where our information that went into data stores helped the bot in coming up with a greater accurate answer. So the chatbot could index publicly available knowledge about ING. It could retrieve relevant response before coming up with an answer. And then it could get more contextual data, more personalized answers. And this all made sure that our responses were more factual and accurate. So this pattern specifically for us, we used Google Dialogflow data stores, is something that's highly recommended for any use case where you want accurate information, especially one for a bank. So this was our second solution. We move on. As I mentioned, for us, it's a multi-tenant platform. We are live with 6 countries. When we integrate or when we use GenAI, we still want to be sure that our tenants have fortified scalability. What does that mean, fortify scalability, a long word? It's important to isolate consumers and services from cascading failures. Meaning that if one tenant, for example, a country like Netherlands, has a problem with their chatbot, it does not affect other countries in their performance. That's as simple as that. So a surge in demand for chatbot conversations in one tenant do not affect the other tenant. That's the goal we are trying to achieve here. This is especially relevant because of GenAI, because GenAI-powered conversations have a plethora of problems, slowness, surge, etc. And the problem is not just that, it's also about the variance. With GenAI-powered conversations, response times can be unpredictable. That means that some questions can be answered within seconds, while some might take a few, let's say, more than 10 seconds. Some might require more AI processing. This variance, right, this differences in demands and surges across various, say, bots, traditional GenAI bots, is something that can be very dangerous for a shared architecture like we had. We have one platform serving all the countries, all the tenants. Some of them are NLP-based, some of them are non-NLP. But some of them are critical, like fraud, and some of them are less critical. We want to make sure that we have fortified the scalability for all these tenants. The surge in demand, the slowness of one tenant should not affect the other. And that's the goal we were trying to reach, especially considering that we have some very critical conversations with our customer as well, like fraud. So how did we go about it? To solve this, we basically doubled down on something we already had. It's called as a bulkhead design pattern. It's a scalability safeguard that physically and logically isolates workloads per tenant. That means you prevent performance bottleneck in one place, affecting the performance of other places. So you prevent failures from cascading in one place to another. It's a well-known pattern, but it's more and more being used in enterprise systems. The concept comes from ships, where you have watertight compartments in ships known as bulkheads. And what we do with this pattern in our platform is that we ensure that each tenant has its own sealed execution environment. So we introduce resource allocation at the lowest level, lowest meaning up to the level of a virtual agent. And this means that we can potentially avoid resource starvation. We can ensure that each tenant has its own compute, memory, and execution threads proportionally to their AI demand, and thus avoiding bottlenecks. Just a picture to show. So you can see tenants here with their own resource pool and their own agents. The idea being that each tenant has its own resource pool and its own configuration. They get a dedicated resource pool, which means that if tenant B, for example, has a very high demand because it's powered by GenAI, then it doesn't overload other tenants or disrupt others. It also means that all AI queues are managed independently. So if there is a long-running conversation, that's a different queue from a normal conversation. So that's about this pattern, and this basically really helped us achieve true multi-tenancy without performance trade-offs, because we could make sure that with bulkheading, we had strict workload partitioning. We were partitioning workload tenant by tenant. Also, if there were latencies, because if a tenant experienced a seasonal surge in their chatbots, or if they deployed an AI-heavy flow, it doesn't throttle resources from the other tenants. And very important for us that this guaranteed reliability for critical customer interactions. As I said, some interactions are critical than others for customers, for example, fraud. If we dedicate separate resource pools for each interaction, we ensure that one interaction does not affect other. And that's just really helpful. So we ensured that AI-driven conversations at ING always remain smooth, stable, and performance at the same time. So that's the third sort of important solution that we implemented, fortifying scalability. And the last one that I want to mention is, again, about risk. It's about being safe. It's called responsible by design. So while we were very happy that GenAI offers efficient answers, dynamic responses, it also has a lot of risks in it, right? Accuracy, bias, security, compliance. So we had to ensure that when we integrate GenAI into our chatbots, we don't introduce these risks. As a bank, we are very risk averse, and we take a lot of pride in that, in having work on solving risks. So this is where we have this concept of guardrails in GenAI. It's a generic term. A guardrail can be a mechanism, it can be a policy, it can be a software technology, anything that allows you to control the behavior of an LLM. That's what a guardrail is, and guardrails are basically used to prevent harmful, biased, and unintended outputs. And we decided we had to provide not just one, but many, many guardrails. So we had two categories of guardrails that we have for our chatbot. The one category is that we get from Google out of the box because we are using their products. The other ones are more specific to our ecosystem because of us being ING. Let's look at them one by one. Let's look at the Google guardrails first. So if you use Google, if you use their Vertex AI, if you use their Gemini models or any other models, they offer this responsible AI guardrail. What is that? So this is basically, they have a lot of filtering mechanisms that filter user queries and answers. The filtering can be done for derogatory remarks, for sexually explicit content, toxic or violent information. So Google already has a lot of things in place that ensures that both the input and the output is filtered for certain type of content. This makes our chatbot already uh, capable of answering these unsafe queries in a safe way. The next guardrail that we got from Google is called grounding. What happens is that we provide Google with our own data stores. That is the public information we have about ING available. And then each GenAI response, it contains a score of how likely this response is grounded or not, which is correlational to its accuracy, right? So with each response, you get a score like low, medium, high, very high, of how likely this response can be grounded. And then you can decide, you can configure a lowest grounding level. If I configure a grounding level like medium in my project, this basically means that any response which has a higher grounding level than medium will not be shown to the user. So Google already provides you with each response a grounding level, telling how much accurate this can be, and then you can use that grounding level to decide whether you want this answer to be shown or not. We also have this concept of banned phrases in Google. So you as a user of Google's AI models can provide banned phrases. These are specific phrases or words which should not be allowed. So if the generated response, or for that matter, the input prompt, if those contain these banned phrases, then the response is not shown to the user. And we also have a lot of compliance and security protocols that Google has in its SDK that allows us to connect to Dialogflow. So this is what we were offered from Google out of the box, which we had to configure as a user. But on top of all of this, we also added a lot of checks on ING side. Let's look at them one by one. First one is about low agent confidence. So what we have a provision in our platform is that when any Dialogflow agent or when any virtual assistant agent provides an answer, you can configure a confidence level in the platform, saying if the confidence level is below a threshold, then this answer will be rejected. So as a user of the platform, local countries can configure their agents with confidence levels, saying I want at least 70% confidence in this answer. And if we do that, then if the confidence level is below that threshold, you can do a human handover. We also have a pattern known as intent matching for dissatisfaction, which basically means we have a special intent in our flows that recognizes dissatisfaction on the behalf of user. So if the user enters a phrase like, I did not understand or I did not get helped, that's an intent we recognize, and then we hand it over to the human agent. There's also a pattern that we apply, which is known as empty source detection. So basically, this means that whenever we have a response from an LLM, and the LLM says that I do not have a source to confirm this response, I don't have a data source where I can map this response to, then that response is rejected. We don't want to show to our users response from LLM that does not match a particular data source that we own. That's another pattern that we use in our flows to make sure it's accurate. Also, it's not common, but sometimes the users can also try to trick the bot in giving wrong answers. That's why whenever the customer does a rephrasing of the question, we also put a limit on how many times the customer can rephrase their questions, just to make sure nobody's attempting to hack our bots. Finally, I think not finally, one more, but we also have LLMs to help us in protecting from LLMs. So we have GenAI shields. These shields are special, let's say, models that check for the input and output of the data. So these are special agents, special LLMs that look for harmful, undesired content in the input and in the output. And this makes sure that we don't have problems like prompt injection or things like that. So we have special guardrails called shields that check for input and output data. And last but not the least, all data going out of ING data center is anonymized. So because this is sensitive customer data with their card numbers, personal information, address, it could be anything that the customer can type. All data going out of ING is anonymized, and it's de-anonymized coming back in. So we do use LLM to generate responses, but they don't really have knowledge of PIIs or personal customer data, and it still does work. So this is very important because this really ensures that our chatbots can be safely relied upon, can have accurate answers, are not hallucinating, are complying to all the laws, and there's an AI law coming up soon in the next month, I think. So this is where we make sure that we are complying with all the regulations and all the rules. So this is the set of solutions we had that made sure that our chatbot offering was covering what we wanted it to. There were some other engineering feats that I want to mention quickly. What did we do to help our customers? One of the biggest challenge in integrating GenAI into a microservice-based architecture is response times, right? How long do you wait for a GenAI model to respond? So if you are consuming a traditional service, you know it has a predefined timeout, 2 seconds, 1 second. But with GenAI, you can't really predict, right? A complex query might take more, while a simple query might take less time. So this is where we sort of adopted a dynamic timeout pattern, where we intelligently adjust the timeout for each call that we make to Google Dialogflow. This dynamic timeout is tuned on a per message basis. So every time we are calling Dialogflow to answer a customer questions, we are first deriving a timeout value on how much time we should wait for this customer question. So the timeout value is derived based on many factors, but the important one is what is the moving average of the response times from previous messages in this very conversation, the specific Dialogflow agent we are talking to, which model is it, and also the context of the conversation. Is this a query that will take longer time to answer? So this dynamic nature of our timeout ensured that we had latency resilient conversations. We had conversations that were optimal. We were not waiting too long, neither we were timing out too fast. So we were waiting just long enough to get an answer from the LLM. And also, this is important for us to scale, right? Even as the chat volume scale into thousands per minute, the platform ensures that every AI-powered conversation has predictable slowness. There will be slowness, but it's predictable. The other feed that I want to mention is called test sets. It's another feature that helped us in scaling this platform. This feature allowed our local tenants, our bot builders, to upload and schedule test sets for their virtual agents. So the users of our tenant, those who are building the bots, they could upload test sets, and then they could schedule the running of these test sets in our platform. A test set is basically like an input query and an expected response. So if I ask this question, this is what I expect back from the LLM. That's what a test set is. And users could upload multiple test sets, and they could also schedule the running of these test sets. And this is very important because generative AI responses may change based on training data. They might change based on parameter updates. As a user, you have to be really always in control of what that response is. So if you have scheduled these test sets, you are checking for the guardrails in place or not. That's where it really helps to make sure that you are in control of this evolving landscape. So yeah, this feature really helped us in making sure that when a new country rolls out a new chatbot, or if there is changes in the model, we can always check if our guardrails are in place or not, if the bot is not giving incorrect answer. So what did we manage to achieve? The chatbot that we have with GenAI is now live in 3 out of 6 countries, and they're using it not 24/7, but in predefined windows. We have seen improved deflection rates, which means there are fewer customer questions that now lead to a human handover. So that does prove that with this new approach, we have been able to convince our customers with better answers. We've been able to help them better. That's really important because now our agents can do better work. They can focus on more important things. We are also in control of the risk. We do measure how many times a GenAI response was inaccurate, and it sometimes can happen that in spite of all the guardrails in the world, you will skip one or two. But there is a threshold, and we are well below that threshold. And of course, these rollouts that we are doing for our GenAI chatbots, they're controlled. We have a very high level of confidence on how much safety, how much security we get with these changes. So just to conclude, I want to summarize what we have learned with our experience. It's a new technology, it's an interesting one. Don't focus on the trends in the market, focus on what your customer needs. But most importantly, you can't build scalable solutions without scalable platforms as a foundation. For our use case, we have existing CC 2.0 and VA platforms that are scalable by the ground, which means we can plug into them any new technology. And also, when you use a new technology, build on what you have. Don't throw away what you already did. Build on what you have, address the gaps, and then implement strong safeguards. That's it. Thank you.